Hello boys and girls, welcome back to another edition of Crush Lusher Television. Alright, so here we're going to do some holes and vertical asymptotes. So we're going to look at those discontinuities we talked about before, but without a graph. So we just have this thing. Consider f of x equals x squared minus x divided by x squared minus 9. If you're worried about what the hell that looks like, you can always just go to desmos.com, great app or great website, desmos.com, you just type it in and this is what it looks like. And so we're going to find the limit at certain points. So you see that there's an infinite discontinuity here, and there might be another discontinuity somewhere else. So that's what we're going to find out. Okay? So pause the video, write this stuff down, because this is what we're going to do the first part here. Alright, here you go. So let's find the limit as x approaches 2 of f of x first. Alright? So it's easy, we just plug in 2. 2 squared minus 2 minus 6 divided by 2 squared minus 9. So that's 4, no calculator. 4 minus 2 is 2. 2 minus 6 is negative 4. This is 4 minus 9, which is negative 5. Negative divided by negative is positive. So the limit as x approaches 2 from both sides of that graph approaches 4/5 on the y. Cool. All right, that's easy. Limit as x approaches 5 of f of x. Alright, so plug in 5 here. 5 squared minus 5 minus 6 over 5 squared minus 9. So that's going to be 25 minus 5, which is 20. 20 minus 6 is 14. Boom. 25 minus 9, which is 16. Divide those by 2, and you have 7/8. Cool. Alright. So we have two very obvious y values as we approach from both directions. Well, what happens when we put in 3 now? Let's see what happens. 3 squared minus 3 minus 6 over 3 squared minus 9. Okay. 9 minus 3 is 6. 6 minus 6 is 0. Uh-oh. 3 squared is 9. 9 minus 9 is 0. Uh-oh. What the hell is that? Is that 0? Is that undefined? I have no idea what the hell that is. Well, what we call this is indeterminate. Because you can't determine whether this is undefined, whether this is 0, you don't know. And so it's indeterminate. So you have to do something. So because we look at the graph, and so let's look at our work here. So here's part of the graph right here. So as you can see, there's a little hole in the graph at 3. Here's x equals 3 down. There's a hole in the graph. So there is a limit. And I can go on to Desmos also. So I can slide this over. So you see how the x, we get to 3. And it says undefined. You see that hole right there? So there is a limit. So as you approach from the left and the right, there is a value, but there just is nothing there for the actual point. Okay, so there is an actual limit. So what is it going to be? I have no idea. We got to figure it out. So right here, it's between 0.75 and 1. So it's like 0.8 something maybe? I don't know. So this is what we do. We need to manipulate this somehow algebraically. So let's go back to our problem. So since we can't do it, what we're going to do is we're going to solve it by factoring. Check it out. So the limit as x approaches 3 of f of x. And f of x before was x squared minus x minus 6 divided by x squared minus 9. Okay? So we got this here. So we plugged that in, we got indeterminate. So this is what I'm going to do. Oh, I can factor this. So I'm going to factor the numerator. Negative 1, negative 6. What can I add to get negative 1 and multiply to get negative 6? Yeah, it's negative 3 and 2. And so my numerator is going to be x minus 3, x plus 2. And my denominator, I can also factor that. 0 on the top and negative 9 on the bottom because there's no middle term. So that's 3 and negative 3, add to 0 and multiply to negative 9. So that's x plus 3, x minus 3. So I just turned this into this. It's the same thing. If I box this and I get this back, so it's equal. So now I see that, ooh, x minus 3 divided by x minus 3 is 1. And so what I have now is the limit as x approaches 3 of f of x. I just simplified this, is x plus 2 divided by x plus 3. And so now I just plug in again. What's on there? So that's going to be no. So it's going to be 3 plus 2 divided by 3 plus 3, which is 5, 6, which is a decimal 0.83 repeating. Which makes sense because when I go back here, this limit here is between 0.75 and 1, 0.83. Yeah, that looks about right. We got it. All right, cool. So, removable discontinuity or hole. So how do you know there is one right here? So how do you know there is one? Well, write this down, pause the video. A point at which the limit as x approaches c, any value of f of x exists. The limit exists, but the point is undefined. So the limit exists, but the point is undefined, so therefore you got a hole. So there is a hole in the graph at x equals 3 of this function. Let's try another. Okay? So, write this one down. Limit as x approaches 5 of x squared minus 25 over x squared minus 8x plus 15. Write it down. Boom. All right, let's do it. Let's do it. Let's do it. Here we go. So here's my notes right here about removable discontinuity. So let's see what happens. Always plug in first. Don't assume that we're going to get 0 to 0. Always check it out first. So 5 squared minus 25 over 5 squared minus 8 times 5 plus 15. 25 minus 25 is 0. 25 minus 40 is negative 15. Plus 15 is 0. Uh-oh. Indeterminate. So what am I going to do? Factor. Yeah, we're going to factor. Factor that numerator. 0 on the top, negative 25 on the bottom, 5 and negative 5. And we're going to factor that denominator. Negative 8 and 15. What adds to negative 8 multiplies to 15? Yeah, negative 5, negative 3. So now, the limit as x approaches 5, make sure you write the same notation I do. Notation is very important. The numerator is x plus 5, x minus 5. The denominator is x minus 5, x minus 3 when you factor it out. And I see x minus 5 divided by x minus 5 is 1. Last step, the limit as x approaches 5 is x plus 5 divided by x minus 3. Plug in 5 here. 5 plus 5 over 5 minus 3, which is 10 divided by 2, which is 5. Got it. So what do we find out? We have a removable discontinuity at x equals 5. And the limit as x approaches 5 of f of x equals 5. Cool. So there's a hole at 5, and the y value that approaches from the left and right is also 5. Cool. Let's do some more practice. How about some more practice? Get it? Some more practice. Ha 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 ha. Pause the video, see if you can get these two, okay? Ooh, here are the answers. You get it? Negative 2/5 and 6. Negative 2/5 and 6. Well, here's the answer to this one. I'm actually going to do this one on the right, okay? See if we can get it. That one's a little bit tougher. All right? This one, negative 2 over 5. Got it? All right, so let's do the one on the right as a final problem. Get to the problem. All right. So this one's a little bit different. First step, always, plug in 0, 0. So you get 0 plus 3 squared minus 9 over 0. 3 squared is 9. 9 minus 9 is 0 over 0. Indeterminate. Bam. Okay, so that signals that there is a hole at x equals 0. It's a hole in the graph. Okay, so but what is the limit? As we approach from the left and the right, what are we going to get? That's what we have to figure out. So factoring isn't really going to do much here, but I can do the box method here. You can do the box method, x, 3x plus 3. So that's going to be x squared, 3x, 3x, and 9. And so now this right here is going to be x squared plus 3x is 6x plus 9 minus 9. Bring that minus 9 down here. So this is the box thing, and then I'm just bringing the negative 9 down over x. Okay. Now 9 minus 9 is 0. So this equals x squared plus 6x over x. Alright, let's keep it going. Ooh, what can I factor out? What do these have in common? Yeah, they both have an x. So here's the factoring part. So I can take out an x from both. Cool. Because when you distribute x squared plus 6x, x divided by x is 1. And so now, always put the limit. It's the last part. The limit as x approaches 0. Now this whole thing was simplified to this, x plus 6. So that's going to be, plug in 0 again, 0 plus 6 equals 6. So there's a hole at x equals 0, but the limit as x approaches 0 is 6. Cool. If you want to see it, just put this into Desmo so you can see what's going on with the graph. Nice job, everybody. Good work. Part 2 is coming on Wednesday. Good work.